One major advantage of using the standard error formula instead of the method that we used the first time is that when you use a standard error formula, you don't have to sort the population into all possible samples and then calculate the mean of each sample. You can probably guess that in a real study, when you're taking a sample from a big population, it's not possible to calculate the means of all possible samples. So in an actual study, you would have to use the standard error formula because it wouldn't even be possible to sort out the population into all possible samples. I'll show you an example of how this formula could be used in a real study. Imagine that I'm randomly selecting 50 JFK students to be my sample, and I'm recording the heights of the 50 people, and I'm calculating the mean of my sample to estimate the mean of the entire university. And in my study, I want to calculate the standard error to be able to get an idea of how far off target my sample mean is likely to be. If I know what the standard deviation of the heights in the JFK population equals, I can plug that into the formula right here. And if I know the number of people in the JFK population, I can plug that in right here. And right here, I'll just plug in my sample size of 50. And then this formula would actually give me the standard error for all possible samples of 50 students that I might end up selecting from the population. And then that standard error would tell me how far off target my sample mean is likely to be, or how much accuracy I can expect. Now you might be wondering, what would you do if you don't know the population standard deviation or the population size? Well, that's actually an issue that we'll get into in the next video.